Hi, welcome to this lesson on number patterns, arithmetic series. Let's have a look at question 5 of solving an arithmetic series problem. Consider this arithmetic sequence: 15, 10, 5, 0, -5, -10, and so on. For what value of n will the series have a value of -195? So let's first of all understand what this question is asking. We're given an arithmetic sequence first of all, which will be able to form a plus n minus 1 times d, where n is a natural number. And we want to find which value of n, so we want to find n, that's the goal. So in your final solution, it must be n equals something. Will the series, which is your s sub n, have a value of -195? So you want to find the value of n that gives the sum of the first n terms being -195. Okay. So let's try and get the arithmetic sequence to find a and to find d. Okay, because we're going to end up using the sum formula s sub n equals n over 2 times a plus, or 2a plus n minus 1 times d. I'm not using the second formula because I don't know what that last term of the sequence will be, that when you add it all up to that last term, you get -195. Okay, so your safest bet is always to go with the first formula. The second formula only really gets used if you definitely know the last term of the sequence, the number of terms you're adding up, and the first term. Okay, so I need my a, I need my d, and I'm looking for n, so that's what you're going to solve for. Okay, and you know that the Sn value is -195. So first of all, what is my first term here in this sequence? A, it's 15. So how do I get 15 to 10, 10 to 5, 5 to 0? Looks like I'm subtracting 5 each time. So that's my common difference, d, -5. Okay, so knowing that, I can then say, therefore, -195 equals n over 2 into 2 times 15 plus n minus 1 times -5. So the goal is to solve for n here. So you get -195 equals n over 2. 2 times 15 is 30. N times -5 is -5n. -1 times -5 is +5. So let's clean that up a bit. So you have -195 equals n over 2 into 30 plus 5 is 35 minus 5n. So I'm going to multiply both sides of 2 now in this equation to get rid of that denominator term there. So therefore, n times 35 minus 5n equals, well, -195 times 2 is going to give you -390. Okay. Now I'm going to expand that n out. So I'm going to get 35n minus 5n squared equals -390. Next, I'm going to move all these left-hand terms to the right so I can get a positive n squared term. So I'm going to get 5n squared. The positive 35n becomes -35n, and that -390 stays where it is. That's equals to 0. Now I have a quadratic equation in the general form ax squared plus bx plus c equals 0. I can either try and factorize it using the trial and error method. I can try use the quadratic formula. I can try complete the square. Because the numbers are quite large here, I think I'm going to go ahead and use the quadratic formula. So recall the quadratic formula on the side here. X is equal to -b plus or minus the square root of the discriminant term, b squared minus 4ac, all over 2a. A in this context is 5, the coefficient of n squared. B is the coefficient of n, which is -35. And c is the constant term, which is -390. So therefore, plugging in for n, I get -35 plus or minus square root of -35 squared minus 4 times a, which is 5, times c, which is -390, all over 2 times 5. So I'm going to get potentially two n values here. Let's see what they are. So in my calculator, okay, I'm going to have negative 35, which should just be positive 35. Let's do the plus term first. So that's b squared, negative 35 squared, minus 4 times a, which is 5, times c, which is negative 390, all divided by 2 times a, which is 2 times 5. So I get n equals 13 for the first one, or if I do the negative one now, delete, minus negative 6. Now, again, algebraically, that is correct. There are two solutions for n that satisfy this equation here. However, from the context of the problem, n has to be a natural number because we're dealing with the position of the term. It doesn't make sense to talk about the negative 6th position, okay? So the correct solution here will be when n equals 13. So at the 13th position of that sequence, if you add up from the first term to the 13th term, the final answer that will be output is negative 195. So basically, if you added up 15 plus 10 plus 5 plus 0 plus negative 5 plus negative 10, all the way up to the 13th term, which will be what? Well, we can work that out using the general sequence form here. So that'll be T13, which is 15 plus 12 times negative 5. So that's 15, and 12 times negative 5, that's negative 60. So I get negative 45. So if you add it all the way up to negative 45, then the final answer you get is negative 195. And that is what this problem is saying. For what value of n will the sum of the first n terms give you an output of negative 195? In this case, it is all the way up to the 13th term. So the sum of the first 13 terms of this sequence will give you an output value of negative 195. All right, and that's how you would solve this type of problem. I'll see you in the next one.